Hello. Now, today we're going to look at sample spaces in more detail and look at some pictures that we can draw, some diagrams we can draw to make those sample spaces easier to figure out. Because in some probability questions, figuring out what all of the possible outcomes are gets quite confusing. So it's helpful to have diagrams to guide us as to what all of our possible outcomes are. And the two methods we're going to use today are called two-way tables and tree diagrams. So to begin with, we're just going to list the sample space for the situation that we are given. So list all possible outcomes again means list the sample space. So it's important we know that language in connection with our questions. So part one, again, is the sample space. It's all of our possible outcomes. Well, what situation have we got here? We have a spinner is spun and a coin is flipped. So we have the spinner drawn for us here. A spinner is not something we're expected to know what version of a spinner, or so they should give us a picture or tell us exactly what the outcomes are if they ask us for a spinner. Because it's not like a coin where we're supposed to know what a coin is, or a dice where we're supposed to know it has 6 sides. So a spinner, they'll give us a picture for. So here I have a triangle shaped spinner, and we'd spin it around. There'd be a stick going through the middle of this, and we'd spin the thing around, and whichever side 1, 2, 3 it fell down on is the side that we are going to say that we picked. So that's how our spinner works. You could also have one that has an arrow in the middle and you spin it around, and we're saying that these three spaces are equal, so each outcome here is equally likely. Just like when we're rolling a dice, each outcome is equally likely, or flipping a coin, head or tail is equally likely for fair coins and dice. So let's do out our sample space. What are the different things that can happen? Well, I could get a head on my coin. So what are the different situations? If I definitely get a head in my coin, what are the different situations I could get on the spinner? Well, I could get a head on the coin and a 1 on the spinner, or I could get a head on the coin and a 2 on the spinner, or I could get a head on the coin and a 3 on the spinner, or I could get a tail and a 1 on the spinner, a tail and a 2 on the spinner, and a tail and a 3 on the spinner. And that covers all of my possible outcomes. And just to link it back to our fundamental principle of counting again, how many outcomes did we get? We got 1, 2, 3, 4, 5, 6. So we have a total of 6 possible outcomes. So if we wanted to know all of our possible outcomes, we could list out our sample space. Or if we just needed to know all of our possible outcomes, we have 3 possible outcomes on our spinner, and we have 2 possible outcomes on our coin. We could get a head or a tail. So if we multiply that together, we get 6 total possible outcomes. So we can see that our sample space tells us how many possible outcomes we have, and we also have our fundamental principle of counting, where we multiply the number of options in one thing by the number of options in the other, and we get the total number of possible options, the total number of possible outcomes. Now, let's get on to some new stuff, because we already know about these two things from the last day. Here, our sample space isn't too hard to figure out, but it's already getting a little bit confusing. We have so many different options. So let's look at a two-way table to help us keep track of this a little bit better. And I've actually drawn this out a little bit like a two-way table already. So we're going to go to our two-way table. So our two-way table means a table that is going to have columns and rows. So it goes two ways. So we're going to break it up like this, and we're going to have our coin, we'll say, on this axis here, and we're going to have our spinner going across the top here. So what are our outcomes on our coin? Well, we could have a head or a tail as outcomes on our coin. And what are the outcomes we could have on our spinner? We could have a 1, a 2, or a 3. And I need to give myself more space, obviously enough, on my left to right, because I am going to be writing from left to right. So that's why I've left these wider this way. Now, the way that this table works is that if I get a head on the coin and a 1 on the spinner, I'd end up in this box here. So I get a head on the coin and a 1 on the spinner. A head on the coin, a 2 on the spinner. Switching around a little bit, a tail on the coin and a 2 on the spinner. You can just do them sequentially. I'm breaking the order so it's easier to see what rule I am following. So a tail on the coin, a 3 on the spinner. A head on the coin, a 3 on the spinner. A tail on the coin, a 1 on the spinner. Now I can see that I have ended up with exactly the same thing as I did for my sample space, but because I have this structure around me, I'm very unlikely to make a mistake. I can see that all of my boxes have to get filled in with all of my different possible outcomes. So the two-way table is an excellent way of guaranteeing we don't miss out any possible outcomes. Say if we were asked that two dice are rolled, we'd have 6 possible outcomes for one of them and 6 possible outcomes for the other. If we tried to list them all out, it would be very easy to leave one out, to make a mistake and leave one out. But if we draw a two-way table with 6 numbers going this way and 6 numbers going down, it'll be a big table, but I'll be able to see that every single box needs to get filled in, so I won't miss any possible outcomes. So that's why the two-way table can be so helpful. And the tree diagram, the next thing we're going to do, is very similar in that it helps us. It doesn't look particularly similar. So our tree diagram looks like this. So which one will we start with? We'll start with the coin. So when I flip a coin, I start out here where I haven't done anything yet, and I'm going to branch out from this point. So when I flip a coin, I could get a head, or I could get a tail. So I start out here, I haven't done anything yet. Here, I've flipped a coin, and I could have either gotten, so there's one possible future where I got a head, or one possible future where I got a tail. And there'd be a probability of a half for each of them. And then if I go from here, if I go from my 2 possible outcomes here and then spin my spinner, if I start here from a head, I could have gotten a 1 on my spinner, a 2 on my spinner, or a 3 on my spinner. So this is a set of possible outcomes. I could have gotten a head and then gotten a 1, gotten a head and then gotten a 2, gotten a head and then gotten a 3. Or I could have gone the other way. I could have gotten a tail, and I could then, when I spin my spinner, I could have gotten a 1, and then I could have gotten a 2, or I could have gotten a 3. And the probability of each of these would be a third. So all of them have the same probability. I have a 1 in 3 chance of getting each one of my numbers because they're all equally likely, and I have 3 possible ones. So the probability of getting a 2, there's only 1 2 there, so it's going to be 1 out of 3 possible outcomes. So those are all of my probabilities written on my tree diagram, and writing them in on the arms or the branches of the tree diagram is a very good way to keep track of what we're doing. So let's list out all of our possible outcomes here. So we start out, we haven't done anything yet. We could have gotten a head and then a 1, a head and then a 1, a head and then a 2, a head and then a 3. You can see how this is working out the same as our sample space. We could have gotten a tail and then a 1, a tail and then a 2, oops, and a tail, and then a 3. So those are all of the different possible outcomes that I could have had with my tree diagram, and I can see that they give me the same results as my two-way table or listing out my sample space. But this can be very helpful for figuring out more complex situations, and this can be very helpful for not missing any possible outcomes. So let's look at our last idea here. It's a probability question. What is the probability of a prime number and a tail? So what's the probability of a prime? I'm going to write this in probability notation type language. So P for probability, open a bracket, prime, and a tail. T for tail. So what's the probability of prime and tail? Well, the way that I work this out is to see how many possible outcomes I have in total. I know that probability is equal to wanted over total. So how many things do I have in total? My probability of prime and tail. Well, what's the total? I already worked that out, and I can see it from my sample spaces and from everything. I have 1, 2, 3, 4, 5, 6 total things that can happen. And how many of them meet this criteria? How many of them are described by this? How many outcomes do I get where I have a tail and a prime number on my spinner? Well, all of these have heads, so I can eliminate them. None of them are candidates because they have heads in them, not tails. So then I look to my tails outcome, and I look here and I said, well, I got a tail and a 1. Is a 1 a prime number? No. I get a tail and a 2. Well, a 2 is a prime number, so this one would count. And then a tail and a 3, and a 3 is a prime number. So I would have 2 outcomes that are described here. So I would have 2 outcomes out of 6 would meet my description. And when I put that in my calculator, I would get a third. So there'd be a probability of a third of getting a prime number on my spinner and a tail on my coin. And that is how we can use our tree diagram to figure out which situations meet our criteria. We can also use our two-way table or just listing out our sample space. All of them are important. We need to know all of them and be fairly comfortable with them. And that is the different tools that we need for now.